So today our focus is going to be on writing these absolute value inequalities in word problems. So let's take a look how some of this might look like, right? It says, now that you have seen the process to solve absolute value inequalities, where can we use these in real world situations? So let's go over some of these. It says, example number one, pretend that you are allowed to go within it should be 9 miles per hour of the speed limit of 65 miles per hour without getting a ticket. Write an absolute value inequality that models this situation. Write an inequality that shows the speed you are allowed to go without getting a ticket. So here we go. We want basically to calculate a distance, right? And remember that a distance between our target number and your actual number is never going to be negative. So, like for example, if I was going to go to Mexico, right? Mexico is about 120 miles away going one way. Well, going back from Mexico here, we wouldn't say that that distance is negative 120. You'd still say like, oh no, well the distance from Mexico to back over here is also 120 miles. Essentially, what I'm saying is what we need to do is we need to find how far apart numbers are, and we do that by subtraction. But because we're talking about how far away something is or the distance to that number, that distance can't be negative. We're going to take that to be the absolute value. And we're going to relate it to what the acceptable range is. Like, okay, well, what's the cushion that they give me? Like, it can be like 4 units away, 5 units away, 6 units away, and still be okay. So the way they have it set up here is this is going to be your actual amount. This is going to be your target number. Like, what are you trying to be really close to? And then this is going to be like your room for error, right? Like, how much can you get away with? So in this case, we don't know your actual speed, but I know that my target speed is 65 miles. So I want to know, is the distance between my speed and the target speed, remember we calculate distance by subtraction, and here's my cushion. It has to be less than 9 miles per hour in order for me not to get a ticket. So there's my inequality. I'm going to go ahead and start solving for it now. And then hopefully once we see it, we'll see why this makes sense. So again, this is my actual speed. This is the target speed. And this is the cushion, the 9 mile per hour cushion that they're giving me. Okay. If I were to solve this, remember that this would be the sandwich method, right? Because I have a positive number, but the arrow is pointing to the left. So sandwich method, I'm going to take that 9, I'm going to stick it in the front. What I get is negative 9 is less than x minus 65 is less than positive 9. And we're going to go ahead and add 65 to all sides. These are going to cancel, and I end up with, what would that be? 54 is less than x is less than 74. What they're saying is as long as I'm going more than 54 miles per hour or less than 74 miles per hour. Why does that sound wrong? That's because it is wrong. Let me go ahead and change that again. That should be 56. I was about to say like something doesn't sound right. As long as I'm going more than 56 miles per hour but less than 74 miles per hour, I should not be getting a ticket. All right. So there's my inequality that shows which speeds are safe for me not to get a ticket. According to this problem, I don't want you to grow up and say like, oh, Ms. Ulichuga said you can go within 9 miles per hour. I'm just saying for this particular problem, that's what it would be. Okay. All right. Here's example number 2. It says in a poll of 100 people, Misty's approval rating as a dog is 78% with a 3% margin of error. Write an absolute value inequality that models this situation. Solve the inequality. So again, our target is 78%. We don't know what the actual approval rating is. We know it's somewhere around there with a 3% error. This is how much of a margin they're giving me. So I'm going to go ahead and calculate the distance. I'm going to actually write let x be the dog's approval rating. Be Misty's approval rating. I want the distance between my approval rating and the 78% to be within 3%. So I'm going to take Misty's approval rating and I want to find that distance between that and 78%. I want that margin of error to be less than 3%. With a 3% margin of error. So I guess it could be equal to 3% as well. So we're going to go ahead and put that equal sign. 3% would still be good. Again, it's pointing to the left, and that's a positive number. We're going to use the shortcut, the sandwich method. We're going to swing that -3 to the front and make it negative. So I get -3 is less than or equal to x minus 78 is less than or equal to 3. We're going to go ahead and add 78 to all sides. And I get 75 is less than or equal to x is less than or equal to 81. And there's my interval. All right, let's take a look at the next one. It says, according to the NFL rules, a football used in a game must have an air pressure of 13 psi with a margin of 0.5 psi. Write an absolute value inequality that models the range of acceptable air pressure. So I'm going to say let x represent the amount of air pressure in an acceptable ball. What I want to do is I want to make sure that this x, that amount of air pressure, the distance between that and my target is 13. So I'm going to subtract 13. I want that to be less than 0.5. Must have an air pressure of 0.5. Yep. So it can be less than or equal to 0.5 and still be okay. All right. Again, it's pointing to the left. I wish there were some problems here that pointed to the right, but it looks like that's not going to happen. So it's pointing to the left. So we're going to go ahead and take that number, move it to the front, and make it a negative number. So I get negative 0.5 is less than or equal to x minus 13 is less than or equal to 0.5. We're going to add 13 to each side. These are going to cancel, and you get 12.5 is less than or equal to x is less than or equal to 13.5. What that's telling you is the acceptable amount of air pressure is somewhere between 12.5 and 13.5 psi. Okay. And then our last one, as far as it relates to word problems, it says for the last 20 years, Mr. Bean has weighed 120 pounds, give or take 4 pounds. Write a compound inequality represent all possible weights for Mr. Bean. So I know Mr. Bean is somewhere around 120 pounds. I don't know what his actual weight is yet. So we're going to say let x represent Mr. Bean's actual weight. When they say give or take 4 pounds, they didn't say less than or equal to. So we're going to assume that you can be equal to. So I'm going to write absolute value. Again, I don't know his weight, but I know that his target weight should be around 120 pounds. So x minus 120. And the cushion that they're giving me is 4 pounds. So I'm going to write less than or equal to 4. We're going to go ahead and take that 4. I'm going to swing it to the front. That's going to be negative 4 is less than or equal to x minus 120. Less than or equal to positive 4. I'm going to add 120 to all sides. These are going to cancel, and I get 116 is less than or equal to x is less than or equal to 124. That means Mr. Bean's weight must have been somewhere between 116 and 124 pounds. All right, these last couple problems have just some review, which is really good to see. Let's go ahead and start trying these out. I have negative 8 times the absolute value of p over 2 is greater than or equal to negative 12. Remember that we need to go ahead and isolate this absolute value first. So we're going to go ahead and divide both sides by negative 8. I end up with p over 2 Because I'm dividing by -8, I need to switch that inequality so that it goes the other way. And that gives me 12 over 8. Remember, we really should simplify that. So when I move this over, I'm actually going to go ahead and simplify it here. I'm going to take that 12 over 8. I'm going to move it over this way. And I'm going to go ahead and simplify that. 12 over 8, because I can divide top and bottom by 4, that should be 3 over 2. So it's going to be -3 over 2 is less than or equal to p over 2 is less than or equal to 3 over 2. Now I'm going to multiply everything by 2 to get rid of the divided by 2 on the bottom. And this is actually really nice because this cancels, this cancels, this cancels, this cancels, and this cancels, this cancels. I'm left with -3 is less than or equal to p is less than or equal to 3. So on my number line, I would circle the -3, I would circle the 3. Because it's a compact, I would, my p's are stuck between those numbers, so I'm definitely going to shade the stuff in between, and I'm going to shade it. And if I were to write it in interval notation, it would be start from -3 and at +3. Okay, let's try one more. I'm going to go ahead and subtract one from each side, so I end up with -3 times the absolute value of 9 plus 9n is less than -54. I'm going to divide both sides by -3. Remember, when you divide by -3, you need to switch the symbol on the inequality. So that's absolute value of 9 plus 9n is greater than, what is that? That is 18. In this case, because my absolute value is pointing to the right, this is the split method. So I'm going to split this into two different inequalities. The first inequality, you're just going to keep everything. So that's going to be 9 plus 9n is greater than 18. This one you're going to keep. The other one you're going to keep flip. So we're going to go KFF. And so you're going to keep the 9 plus 9n. You're going to flip the inequality the other way, and you're going to flip the 18 into a -18. All right, we're going to go ahead and subtract and solve each one individually. So subtract 9. That's 9n is greater than 9. And divide both sides by 9. N is greater than 1. Or, I forgot that word, or we really do need that word. We're going to go ahead and subtract 9 from each side on this side. I get 9n is less than -27. Divide both sides by 9. I get n is less than -3. So I have two different sets. The first set, I have n is less than -3. I'm going to circle the -3, and I want the numbers less than that. I am not going to shade it because there is no equal sign on the bottom. And then as far as n is greater than 1, I'm going to circle the 1, and I'm going to shade to the right. Again, I'm not going to shade it because they have that there's no equal sign underneath. Hey, in this case, I have two sets. So if I want to write this in interval notation, I need to write two sets. The first set, where does it start? It starts at -infinity, and it ends at -3. The other set starts at 1 and ends at infinity. There's parentheses everywhere. Infinity is always at parentheses. And since I'm not shading the boundary points, I'm going to use parentheses as well. This would be a great answer, except I'm missing something. I'm missing the union symbol. We need to put a U in the middle. Okay, I know we think we're done. On the backside, though, I do want to add one extra practice problem just because I feel like it's going to be super important for you guys to have this. So let's, on the backside, go ahead and copy down this problem. Magic, check that out. Go ahead and copy that down. This is going to be a bonus problem. I promise it's going to be the last one, but I do want you to see something like this. That way you're not surprised when you do the homework later on today. It says the distance between a number and 11 is more than 4. Write an inequality expressing this situation. So they're telling me I'm talking about a distance between a number. I don't know what that is. So we're going to say let x represent the number. So then I want the distance between that number and my target is 11, but I want that distance to be more than 4. So let's see. Because I'm talking about a distance, I'm going to go ahead and write absolute value of x minus my target number is 11. And this time they're telling me they want it to be more than 4. So So I'm going to go this way because I want that distance to be greater than 4. Hey, in that case, it's going to be one of those word problems where you are going to have to split this up into two different inequalities. The first inequality you're going to keep. So that's going to be x minus 11 is greater than 4. The second inequality you're going to keep flip. So you're going to keep the x minus 11. You're going to flip the sign of that inequality. You're going to flip that 4 into a negative 4. Now we're just going to go ahead and solve each one. I got x is greater than 15, or on this other side, you got x is less than 7. So if I were to draw this on a number line, I would have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I guess I need to make my number line a little bigger, huh? 15, 16, 17, 18. So let's see. I need my x's to be greater than 15, or I need my x's to be less than 7. And again, if I take a look, remember, I want my numbers to be 4 units away or more from 11. 1, 2, 3, 4. That's all of these numbers. 1, 2, 3, 4. That's all of these numbers. So that makes sense that these would be the numbers that work out. Okay. If I'm going to write this in interval notation, remember that we need to go ahead and talk about two different sets. The first set is this one over here. It starts at negative infinity and ends at 7. Because infinities always have parentheses and it's not shaded in, we're going to go parentheses. On the other side, my inequality starts at 15 and moves on to infinity. So it starts at 15, moves on to infinity. Again, same reasons. We're going to go parentheses. Do not forget the U in the middle. All right, that takes care of all the notes, including the bonus note. Thank you for doing that for me. If you have any questions, as always, feel free to ask.